Hello students, this video is about complementary angles having to do with trigonometry. And in this lesson, we are going to use the relationship between the sine and cosine of complementary angles. And we're going to discuss the vocabulary cofunction. So, the acute angles of a right triangle. If you have a right triangle, okay, and we know it's 90, that's a right triangle. The two acute angles, okay, being here and here, those two angles are complementary. Complementary meaning that they add to 90. If the measure of one of them is given, so if I were to tell you that this angle is 39 degrees, the measure of the second acute angle can be found, right? You can find the measure of this angle because you know that all of the angles in the triangle add up to 180. And you know that since this is 90, you only have 90 left between these two. Complementary means that these two angles add to 90. And if we do 90 minus 39, we can find the angle of the other corner by subtracting the given measure from 90. So let's relate what we learned, what we know about these two angles adding to 90 to some trigonometry stuff. Let's see if we can find the sine and cosine of the two acute angles in this picture. All right, so let's start with angle A. Let's start with angle A right here. Let's see if we can find the sine and the cosine of angle A. Okay, if I'm trying to find the sine of angle A, I can see that this would be my opposite side. Okay, and here's my hypotenuse and my adjacent. Okay, so my sine is opposite over hypotenuse, so 12 over 37. Okay, now let's find the cosine. The cosine of angle A is going to be the adjacent over the hypotenuse. So adjacent over hypotenuse is 35 over 37. Okay, now let's, instead of looking at angle A, how does this change? If instead of talking about angle A, we talk about the other corner, angle B. If I'm now talking about angle B, well, the hypotenuse is still the same side, right? But now, the side that's opposite is this side over here. This is opposite. And my adjacent, the side that's touching the angle, is now down here. This is my adjacent. Okay, so what are the sine and cosine of angle B? Well, the sine of angle B is opposite over hypotenuse, so 35 over 37. And the cosine of angle B is the adjacent over hypotenuse, 12 over 37. Okay, so now you can see why I'm having you do this relationship here, because we can see that the sine of angle B, 35 over 37, is the same thing we got for the cosine of A, 35 over 37. These are actually the same. And the same thing we got for cosine of B, 12 over 37, is what we got for sine of A. They're the same. Now, this is a principle that will always hold true as long as the two angles we're talking about, in this case A and B, are complementary. So, we can see that the sine of A equals the cosine of B, and the cosine of A equals the sine of B. And this is always true whenever A and B are complementary. So, this is true. This is always true whenever A plus B equals 90. Okay, whenever A plus B equals 90, the sine and the cosine share this relationship. Okay, the trigonometric function of the complement is called the cofunction. So the cofunction So we know what a complement is. Well, the trigonometric function that matches that is called the cofunction. Okay, so sine and cosine are cofunctions of each other. Okay, let's see if we can write the sine of 52 in terms of cosine. Okay, well, we know that the sine of 52 is going to equal the cosine of the complement. So what we have to do is find the complement of 52. In order to find the complement is something that's going to add to 90. So the question becomes 52 plus what gives us 90? So let's say, to find this, we can say the sine of 52 is going to equal the cosine of whatever 90 minus 52 is. Okay? Well, 90 minus 52 is 38. So the sine of 52 equals the cosine of 38. Alright? So those are the same because 52 and 38 are complements. And if you wanted to check it, you could even get out your calculator and put in sine of 52 and see what decimal you get. And put in cosine of 38, you should get the same decimal. Sine 52 is 7.88, 0.788, and when we do this one, we also get 0.788. So that's a check. Okay, let's see if we can do the same thing with cosine. Let's see if we can write cosine 71 in terms of sine. All right, well, the cosine of 71 is going to equal the sine of whatever 90 minus 71 is. 90 minus 71 is 19. So the cosine of 71 equals the sine of 19. Okay, last example. Let's see if we can find the two angles that would satisfy this equation. I have a sine of something equals a cosine of something. Now, since I have these two angles that are a sine and a cosine like this, they're going to be complementary. These two are measures of complementary angles. The sum of the measure of the angles must be 90. So, because I can see that the two are complementary, I'm going to set up an equation where I add them together to equal 90. So I'm going to say x plus 5 plus 4x plus 10 equals 90. Okay, so let's add these together. 4x plus 1x gives us 5x. 5 plus 10 gives us 15. Subtract 15 and divide by 5. We get that x equals 15. So now that we have x, let's just plug x back in to solve for what the angles are. Alright, so let's just substitute back in. Putting 15 into here gives us 15 plus 5, which is 20. And 4 times 15 plus 10 gives us 60 plus 10, which is 70. So it looks like our two angles are 70 degrees and 20 degrees. The measure of the two angles are 20 degrees and 70 degrees. And that is all for this lesson. So, what did we learn? All right, great job.